questions. Surya.
Hello, good afternoon. I am Surya Peddinti. I am the inventor for closed-loop electric propulsion. I have a comment to make, starting with Kevin. Kevin, you mentioned that the third revolution in the aircraft industry has happened with the electric propulsion. So already the fourth revolution is going on right now with me. That's called closed-loop electric propulsion, which gives unlimited range to electric vehicles, aircrafts, ships, submarines, without the need for external recharging. It's self-charged. I would walk you through that later when you have some time. So saying that, the industry has been changing quite fast. There is also some experimentation going on electric turbofans without afterburners. And I believe Siemens did that initially, and then it got transferred to Rolls-Royce. And there were a few other companies which were trying to do that because that gives like low-end thrust as well as transonic speeds or subsonic speeds for passenger aircrafts, which would be a viable option for transportation of people. Where are we with that? I mean, is this industry is mature enough to absorb that technology? Particularly, this question goes to all of you, including Embraer. I'm not sure if you're investing into that technology.
So I'll say that it sounds very exciting. I sincerely want a future where technologies like that could be viable. And it seems like that would hit the top end of the aviation market and not just these early markets that are currently being impacted. I am not aware of the current state of that technology, and certainly it's not what we would be incorporating in any of these kind of practical, compelling early stage products. But as we see technology advance, our team is certainly engaging with those groups to understand when they will hit, call it a TRL6, and be able to be incorporated into a product that could pass certification. I'll open it up to others to address.
Yeah, I think we have more or less the same answer. So currently, by the way, the design is frozen. Any change now with the technology will delay us tremendously in terms of time to market and certification. So, but we are looking all the time around to see if there is another opportunity to be included in the next design. So this is, of course, something we will not exclude.
I think it's interesting to look at future technology, particularly around propulsion. Electric motors are incredibly efficient at turning electrons into torque. But the other part of the design equation that's challenging is the drag aspect. We can make airplanes very, very slippery, but whatever drag component there is, it's impacted dramatically by velocity, in fact, velocity squared. So in dealing with the initial speed range that the panel is working with here, we have an approach that balances the propulsion system and energy system against that velocity and drag. You look at aircraft that go faster than that, and that drag component, of course, goes up squared. So it's a very great challenge. It gets even harder as we go faster. It's not linear as it is with weight. So we're challenged by that. We look forward to that. But a great starting point is where we are today with kind of the velocity that we're working with.
Totally agree. For Embraer, like I mentioned during the presentation, this effort is a collaborative effort for everybody here in the industry. Everybody's sharing the same view, believing in this future will bring innovative solutions and changing people's lives. So in the point of view of Embraer, we understand that we have our competences and others in the industry has other competences that we can collaborate and create these good solutions for everybody. So each one in your expertise can contribute, and we'll be able to create marvelous solutions.
Thank you. And one more question. This is to Doug. Uh, sorry, George. I'm sorry. I saw your E-Flyer demo here as well as in several websites. Spectacular aircraft. Congratulations for it. And in addition to training, I am also already I'm seeing that there is a great potential for it to be used in CAS as well as coin operations. If you fit like 350 cal MGs, it would become an excellent coin mission comparable to Super Tucano, which Embraer is having. Have you ever thought about that, military applications on that?
I think there are electric and solar electric platforms that can be used, as you point out, across the board, multi-mission possibilities, both civil and, of course, military. Our focus today, as I mentioned, is the training and then evolving into from the E-Flyer to the E-Flyer 4, where additional missions are possible because of the speed and the payload. And certainly working together with our friends in the defense industry is of great interest to us as well. Initially, however, agility and time to market is gained by a civil commercial approach. As we know, our friends here, when we work in the defense industry, it tends to be a longer process and a more expensive process.
George, I was curious, and I don't know if you mentioned this or not. Did you have a production start date on the E2 and location of where you do the assemblies?
Yeah, so we're based in Centennial, APA, for those of us who are flyers, and at Centennial Airport in Denver, Colorado. And our low-rate initial production will take place there. The ability to go from 50 to 250 aircraft per year. And that's mid-year 2021. So just a little less than 2 years from now, certification and initial production.
Other questions?
Thanks. Question for Kevin. You mentioned you fly. The aircraft now is hybrid. And then you mentioned that you perhaps at a later stage also will have a Jet A hybrid with a combustion engine, I suppose Continental, as they are on board there. Is there also a plan to having like a full electric aircraft on this base? Not at a later stage, but on the 337 base to have a full electric 337?
Absolutely. There is a kind of a stage in the roadmap where it'll make sense for a certain segment of our customer base to go fully electric. I firmly believe in a fully electric future. And I believe that for most segments of the industry, the hybrid is a stepping stone approach, which gives a half-good solution. I think that that's the pragmatic way to go about it, but of course I would prefer if it was fully electric. Our approach with hybrid lends itself quite easily to go fully electric when the time is right. In fact, our systems today are air-gapped. The Skymaster has independent throttles originally for the front engine and for the rear engine. And so we're maintaining that independence between the systems. And so it is quite simply just duplicating that retrofit up in the second engine. Now, in order to make it work, fully electric as a retrofit is very difficult. And George has had experience going through that as well, from the weight and balance of the plane to the payload capacity to the ultimate range that you gain. And so we would likely need to see either a customer who needs only relatively short routes, and we chose to target that 200-mile range, so most of our customers who fly 100 or less or fewer miles per route can do their round trip. There may be some who will want and ask for that fully electric, and we will be prepared to offer it. Right now, it's not being requested, and on principle, we are listening to our customers very intently in order to determine what the right products to bring out are. But certainly, as soon as it can go, it will go fully electric.
And would then, because the electric drivetrain is 160 kilowatt, I think you mentioned, are you disclosing which is the engine or motor manufacturer of this, or is this proprietary motor of yourself?
At this point in time, we're not disclosing it, but I'll mirror what others have said, that there are a number of very good engine or motor manufacturers out there, all of which who create motors that are sufficiently efficient at the power levels required in order to bring it to market. Yeah.
Over here.
Lior, I think I heard you say that you're getting about 240 watt-hours per
level.
kilogram at the pack level.
Yes.
Is that at 80% capacity, or is that new?
That's
and,
it.
and it's packaged as well.
Yeah, it's packaged as well. It's cooled, it's monitored, it includes all the embedded electronics to balance, and that's what we're getting. That's what we're getting with new cells. We get reduction in the performance after 1,000, 2,000, 3,000 cycles. But by the way, that's since we have a full ecosystem here that I haven't discussed. Those old batteries are going to be incorporated into the charger. So you can charge the charger of the aircraft from the current grid without the need to draw new power lines, because now you have to have a lot of power to charge about 1 megawatt hour of batteries. So you can charge the charger out of the grid during the night at low cost and then use it during the day to charge the aircraft. So you don't throw away old batteries, and that goes into our economics as another factor that takes down the direct operation cost.
Other questions? In the back.
What are the new battery technologies that you see coming? Anything from LFP going away from the MNC technology?
So I can keep a long story short. There are lots of batteries technologies there, and I mean, I get, I don't know, 100 emails per month with new batteries technologies, offers, etc. But I can tell you that for now, we wish truly to stick to the current battery technology, because this has been proven in the automobile industry. And I can say that the automobile industry is much more demanding than the aviation industry in terms of dispatch reliability. So we want, for now at least, to go to a proven technology with, I don't know, last week there was an announcement that a Tesla has driven about 900,000 miles or something like that. So yes, I want this type of batteries. I'm going safe with the batteries. There is enough innovation in the current electric propulsion technology for aircraft, at least this is my opinion. And the current batteries are providing enough energy density to meet the performance. So I, in personal, we truly prefer to wait to let other industries that are much more heavily invested into this battery technology area, like starting from cell phones and end up in, of course, all-electric automobiles, to carry the torch there. And then, well, I can tell you that if something is working well in a car, it will probably work well in an aircraft.
Yeah, I would add, and of course we've all seen the exciting technology. It's in a press release probably every week. There's a new chemistry for an anode, there's a new separator, there's a new way of manufacturing, there's a new configuration. And all of that's interesting and exciting to us too. I mean, it's the possibility for what comes next. Maybe it's an STC somewhere down the road to apply to our various aircraft programs. But the key thing for us to bring a product to market is, can it be certified? And has it reached a technology readiness level for certification? Does it meet the rigor of safety and qualification to go on an airplane that you're going to put your grandma and your granddaughter in? And all of that matters, both in reality as well as in perception. So we're working together very closely with industry, all of us, all four of us, to make sure that we achieve that level. Of course, looking to the future, but looking to the future with the quality and qualification to bring it to market.
Yeah, that's perfect. I totally agree. I would just add that this is critical. One of the biggest challenges for the case of urban air mobility, for example, talking about eVTOLs flying on the urban centers. So battery is one of the biggest challenges. This will allow very affordable price in the future with new technologies. And so we totally incentivize this to continue be evolving. We understand that for the current technology, what we have today needs to be tested, and like everybody said here already, but we really incentivize and collaborate with others trying to get the most of this battery, because we understand this is one of the critical challenges we have ahead of us, of course.
And I'll just toss a few numbers out there as well. So historically, we've seen about 8% per year increase in energy density of these batteries. Given that we're probably hitting close to the upper bound of lithium-ion in its current form, the optimizations that we see now are bringing low-rate production batteries at about 400 watt-hours per kilogram. Some are a little bit greater than that. We'll probably cap out in current chemistries at about 500 watt-hours per kilogram. There are other chemistries and other battery types which can take you much above that. When you look at the penalties of their packaging and integration, maybe realistically you're hitting 1,000 watt-hours per kilogram in the far out, call it 10 or more years. But all while we're projecting and watching these things, I mean, it's kind of right across the board. We're looking at what can be certified and is sufficiently safe.
Hi, my question's for Edgar regarding the Embraer eVTOL. I'm curious if you could sort of just walk us through some of the considerations for what led you to the configuration that you show, and I guess the other question, is that the configuration of the aircraft, the final configuration?
Yeah, so this is the evolution of the configuration that we unveiled last year. Was similar to this, but now our team worked on that and we evolved a little bit. We are considering people in everything that we are designing there, so we are interviewing people, talking to them in the streets, understanding their concerns, and we have some feedback, valuable feedback. People don't like to be close to the rotors, things like that, so they are further as possible from the entrance. The entrance needs to be very easy to enter for everyone, considering people with special needs as well. So all these drivers result in this current configuration that we unveiled for you now. The team continues to work on that. Let's see what's next. I cannot disclose any updates for now. This is what we are working on it. And I'm very confident that this will be a successful configuration. Of course, there are big challenges. There are many different configurations that you guys have seen. So this shows how hard is this new market for now, how everybody is learning. So we need to continue working on that. We welcome the competition, different point of view to get to a future of successful solutions for the community. And I'm really confident that we can consider Embraer as considering its competence in the past, its expertise in certification. This is going to be another huge challenge. We talked about battery, but certification for sure It's another huge challenge. We talked yet on this event here. So Embraer can contribute on that, and others will also be a major player on this market. So,
Thank you. And one question for Kevin. When I look at the 337, I guess, which engine is where? Which is the hybrid and which is the electric? And what was the consideration in terms of what you put in the front and what you put in the back?
So the configuration that we're currently flying has the electric drivetrain in the aft of the aircraft. You get a little, even with identical engines in both, you get a little more power out of the aft. We wanted to give ourselves that extra benefit. Similarly, we see early in our roadmap development, we saw an analogy between that aft-mounted propeller and potential aft-mounted ducted fans of like the tailwind, and saw it as a potential test bed in the long run. So that's why we began with that aft-mounted propeller as the fully electric system. Actually, for our Hawaii bird, we're going to be integrating into the nose. And so leaning toward the question of, when will we be able to go fully electric? Roadmap-wise, we want to have the expertise of integrating into both sides. Also, for familiarity and similarity to that roadmap of scaling into other planes, where traditionally you've got a puller prop or tractor prop up front. Flying in Hawaii with that the forward propeller being electric is the configuration for that one. For the certified design, though it's not fully set, we anticipate that it'll be in the tractor prop will be electric, and then the combustion will be in the back.
And on that aircraft, if we look under the nose cowlings, what do we see? Do we see a piston engine and an electric generator in the?
No, so when I say hybrid, it's actually the purest form of hybrid that you can have, where the systems are, one is a pure combustion engine, air-gapped to a separate system, which is your fully electric drivetrain. So the vehicle is hybrid, but
okay.
we have a combustion engine and a fully electric drivetrain that don't touch each other.
Okay, thank you.
Any other questions? Okay, please thank this panel of presenters.